All right, we're going to try something a little ambitious today. We're going to cover 13.7 billion years of history. Yeah, everything from the Big Bang all the way to your breakfast this morning. And, believe it or not, we're going to tie it all together with one very simple, very familiar question. Just take a look at this. It's an egg, unscrambling itself. The yolk and the white are separating, pulling themselves back together, and pouring right back into the shell. And you know deep down in your gut that this is just wrong. It's not how the world works. But the real question is, why? Why does this feel so fundamentally impossible? That feeling right there, that wait, that's not right instinct, well, that leads us straight to what you could call the scrambled egg paradox. And it's a huge puzzle. It pits everything we see around us against one of the most basic laws of physics. So that law is the second law of thermodynamics. You've probably heard it called entropy. And what it says, basically, is that the universe is on a one-way street. It always travels from order and structure, like a nice, neat egg, to disorder and chaos. To mush. A scrambled egg is basically mush. And the universe, by its very nature, loves making mush. And right here, this is the paradox in plain sight. On the one hand, entropy says everything should be breaking down, getting simpler, turning into mush. But just look around. We don't just see mush. We see the exact opposite. We see incredible, staggering complexity. An egg is a complex biological machine. A city is complexity on a scale that's almost impossible to comprehend. And so are you. So how can a universe that's supposed to be falling apart be building all of these amazing things up? Well, it turns out the universe is kind of tricky. It has a creative loophole. And the answer to our scrambled egg paradox lies in something we can call the Goldilocks solution. See, the universe can create complexity, but it can't just do it anywhere. It only happens in these very special, very rare pockets where the conditions are, well, not too hot, not too cold, but just right. These are the Goldilocks conditions. They're these little oases where the universe's march towards mush gets put on pause just long enough for something new and more structured to pop into existence. And here's the really cool part. Complexity builds on itself. It's a step-by-step process. First, you start with some simple ingredients. Then the perfect Goldilocks conditions show up. That allows you to cross a new threshold and bam, something new and more complex emerges. And that new thing, it becomes a building block for the next stage. It really is like climbing a ladder, where each new rung of complexity makes it possible to reach the next one. So let's actually do it. Let's take a quick journey through these thresholds. We're going to wind the clock all the way back 13.7 billion years and watch how the universe uses this exact process to build, well, everything. So here's the cosmic highlight reel. It all kicks off with the Big Bang, the ultimate threshold, creating the universe of just simple atoms and energy. For millions of years, not much happens. But then gravity, our first Goldilocks condition, starts pulling those atoms into huge clouds. And that leads to the next threshold, the first stars flicker on. Now, when those stars die in these massive explosions, they forge all the heavier elements, all the good stuff on the periodic table. Those new ingredients then clump together, making rocky planets, like our own Earth. And finally, on this perfect, just right planet, in the oceans, the right mix of chemistry and energy gives rise to life itself, to DNA. You see the pattern, right? Each step creates the essential ingredients for the next one. And when we say just right, we mean incredibly specific. To get those first stars to even turn on, the center of a simple gas cloud had to be crushed by gravity until it hit a threshold temperature of 10 million degrees Celsius. Not 9 million, not 11, just right. And the results of crossing these thresholds are, well, they're incredibly personal. Just think about this quote. The elements that make up you and me, the carbon in our cells, the oxygen we breathe, even the gold in a ring, none of that existed at the start. It was all forged in the heart of a dying star. We are, quite literally, made of stardust. So what were the Goldilocks conditions for life, right here on Earth? Well, you needed a few things. You needed the right amount of energy from our sun. Not too much, not too little. You needed a whole bunch of different chemical elements, all that stuff made in supernovas. And crucially, you needed a liquid, like water, where all those atoms could just float around, bump into each other, and link up to form complex molecules. Early Earth had all three. It was perfect. So for billions of years, life evolved, driven by the slow, grinding process of DNA. But then, about 200,000 years ago, a brand new threshold was crossed, and this one was driven by a species that had a unique, secret superpower. Our species. So here's the game changer. Think about how DNA learns. It's all based on random copying errors over millions and millions of years. It's incredibly slow. But humans? We developed language, a system so powerful we can share really complex ideas with each other and pass that knowledge down from one generation to the next. This isn't biological evolution anymore. This is cultural evolution, and it moves at lightning speed.
This ability, this superpower, it has a name: collective learning. It's the mechanism that lets knowledge build up within a group, getting more and more complex over time. It's the single biggest thing that separates us from every other animal on the planet. It's the reason we have a history and they don't.
And then, in just the last 200 years, we took our superpower of collective learning and we plugged it into a huge new energy source: fossil fuels. And that simple formula right there, that combination is what created the explosive acceleration and complexity that built our entire modern global world. But this is where our huge cosmic story comes right into the present day. And it comes with a pretty profound warning about the relationship between our incredible power and our deep underlying fragility. Remember that ladder of complexity we were talking about? Well, there's a catch. Every time you climb to a new rung, the things that emerge are not only more complex, they're also more delicate. They're more vulnerable. Our global civilization is easily the most complex thing we know of in the universe, which also makes it the most fragile. And this quote really gets to the heart of our modern problem. Our greatest strength, this engine of collective learning, it's a force so powerful that it's not at all clear if we're controlling it or if it's actually controlling us. And you can see this lack of control in the new kinds of threats we've created for ourselves. Using our collective knowledge, we built nuclear weapons, powerful enough to shatter the entire biosphere. And by burning all those fossil fuels, we are actively messing with the stable, Goldilocks climate that allowed farming and civilization to get started in the first place. We are threatening our own foundations. So we are left at a threshold moment, a turning point, not just in human history, but in the history of our planet. The very same force that gave us the power to understand our entire 13.7 billion year story has also given us the power to end it, which leaves us with a pretty big question. Is this unique superpower, this gift of collective learning, going to be the tool we use to save ourselves, or is it going to be the cause of our own undoing?